we can rewrite the equations in matrix form, and then we can say that we have for the first equation 2 minus 1 0, and that's multiplied by voltage b sub 1, and the resultant vector is 8. The same we can say that we have minus 1 3 and minus 1 corresponding to b sub 2, and then we have 0 minus 1 2 for b sub 3, and the resultant vector is minus 4, and that is our expression in matrix form. In order to find b sub 1, we need to find a determinant. There is going to be determinant 1 divided by general determinant. To find b sub 2, we will do the same, delta or determinant 2 divided by the general determinant, and b sub 3 is going to be the determinant 3 divided by the general determinant. So how do we determine the general determinant? So we will take the numbers of this matrix, and we're going to minus 2, minus 1, 0, minus 1, 3, and minus 1, 0, minus 1, and 2, and then find the determinant for this 3 by 3 matrix. The first thing we need to do is to assign positive sign on the first number, negative on the second, positive on the third one. We go down on this column with a negative, positive, negative, and then with a positive, negative, and positive. We need to select also the column that we're going to use. If we're going to use a column, or if we're going to use a row to solve for this determinant, we're going to use this column. So I'm going to write the positive sign, the number 2, multiply by the minor that is left, that in this case is 3 minus 1 minus 1 and 2. Now we move to the second number, and this second number has a negative minus 1, and we do the same. We cross the column, we cross also the row, and we're left with minus 1, 0, minus 1, and 2. And for the last term, since it's a 0, we just put a 0 there, and that will be all that we need. So let's work on the value of the general determinant. We have 2 times, and this is going to be 3 times 2 is 6, and this is going to be minus 1, and this minus and minus is positive 1, multiplying minus 2, and that's 0, so it's going to be 0 like that. So this is going to be equal to 2 times 5 is equal 10 minus 2. The general determinant is equal to 8. So that's the first value that we need in order to solve b sub 1, b sub 2, and b sub 3. So let's try then to find the determinant 1. For determinant 1, then all we need to do is we just need the general determinant and the resultant, and so what we're going to do is we're going to use the resultant matrix, place that right here as the first column. So that way delta 1 is the first column of the resultant vector, and the rest of the general determinant. And before we do any multiplication, we need to put these signs in front of the numbers. So we start with a positive, negative, positive, negative, positive, negative and positive here, and then negative and positive, positive and negative right here. In this case, I'm going to select this column, and those are the numbers that I'm going to use. And so let's start by multiplying the first number that has a positive in front, then 8, and then a minor is going to be left when I cross this with this, and the minor that is left is 3, minus 1, minus 1, and 2. Then I move to the second number, and that is a 0, so I don't have to worry about that. And so I move to the next number, and the value of the number is minus 4, and when I cross column and row, I'm left with the minor, that is going to be minus 1, 0, 3, and minus 1. So let's go ahead and perform the multiplication. So we have 8 multiply by 3 times 2, that is 6, then minus 1, plus 0, plus minus 4, that multiplies, minus and minus is 1 in this case, and that is a 0, so we can just add the 0 there. So delta 1 is equal to 8 times 5, see, this is 6 minus 1 is 5, plus 0, minus 4, 4 times 1 is 4, so this is 36. So b sub 1 then is equal to delta 1 over delta g, and if you remember, delta g was 8, and now is 36 divided by 8, and this is going to be equal to 4.5 volts. And in order to find v sub 2, we need to remember that v sub 2 is equal to delta 2 divided by delta g. So in order to find delta g, what we need to do is we need to remove the column number 2 and place in column number 2 the values of the resultant vector. So we're going to have 8 over here, 0, and minus 4, like that. And now we can just perform the operations and find the values that we need. So let's go ahead and do that. Before doing that, one of the things we need to do is just put the signs in front of the numbers. And so plus, minus, plus, plus, minus, plus, minus, plus, minus, plus, minus, plus. Second, I need to select if we're going to use a column or we're going to use a row. I prefer to use the column, so I'm going to use this column in order to find the values of the determinant number 2. So I take the first sign, that is plus, with number 2, and I'm going to cross the row and the column, and I'm going to be left with a minor that is going to be 0, minus 1, minus 4, and 2. Then I select the next number that has a negative and then a negative 1 in front of it, and I'm going to cross the column, I'm going to cross the row, and so I'm left with number 8 with 0, minus 4, and 2, and then the last number is a 0, so that's just plus 0 over here. So delta 2, right, is going to be equal to the number 2 multiplied by 2 times 0 is 0. This is negative 4, and then minus and minus is plus 1, and this is going to be multiplied by 8 times 2 is 16, minus 0, plus 0. So delta 2 is equal to minus 8, 2 times minus 4 is minus 8, plus 16 plus 0, and this is going to be equal to 8, right? 1 times 8. So delta 2 is equal to 8, so v sub 2 is equal to delta 2 over delta g, and that's going to be equal to 8 divided by 8, 1 volt. So for v sub 2, we know that the voltage is going to be 1 volt. Now we want to find voltage v sub 3. Voltage v sub 3 is going to be determinant 3 divided by general determinant. For the determinant 3, we take our system of equations, the coefficients of the general matrix, and the resultant vector, and we're going to replace the third column of the coefficient matrix with the resultant vector. We also have to select if we're going to use a column and a row to find the determinant. So in our case, we're going to use the first column. We then need to add the signs in front of the numbers, and we start with number 2 with a positive sign followed by a negative sign, negative, positive, negative, positive, negative, and positive. Then we take the first number, it has a positive in front of it, and we cross the row of the column, and we're left with a matrix 3, 0, minus 1, and minus 4. We take the next number is minus 1. We cross the row, we cross the column, and we're left with a matrix minus 1, 8, minus 1, 4. Then we move to the next number is a 0, and since it's a 0, everything's going to go to 0. Delta 3 is going to be equal to 2 times 3 times minus 4. That's going to be minus 12, and then 0 and minus 1, so we just can add 0. And then minus and minus will give us a positive 1, and minus 1 and minus 4 will give us a 4, and minus 1 minus 8 is going to give us a positive 8 plus 0. Then delta 3 is going to be equal to minus 24 plus 12, and that's going to be equal to negative 12. And now voltage is determinant 3 divided by general determinant, and that is going to be equal to minus 12 divided by 8, and that is a value of minus 1.5 volts for B sub 3.